So, hello guys, how are you all? I hope you all are fine. Let me switch the camera to my face because it is like okay. I think I am visible or okay. Wait a second. Now fine. Now fine. Okay, this is clear. So, hello guys, how are you all? And I hope you all are good and enjoying my video. So, let me scratch this to this place. So okay guys, in this video we will study data structure and some of the contents are given here, which is first is introduction to data structure, and there are 10 topics: introduction, objectives, types of data structures, algorithms. So without wasting our time, let's move to next page. This is representation of a stack. In this video we will try to cover most of the things, and so that introduction to data structure. Okay, this is the starting. Page number 9. So what is data structure? Okay guys, introduction. Data structure, as given there, data structure can be defined as the group of data elements which provides an efficient way of storing and organizing data in the computer. It is nothing but the way of storing the data, okay, and organizing means something is stored. For example, some vegetables are stored in a bucket or in a container, and after that the onion will go in onion category and the potato will go in potato category. So there will this is called organizing, means how will data will be stored. Okay, so this is called storing and organizing data. Means you have to you just nothing to you just have to look at the vegetables, and by or visualizing the vegetables you just have to keep them in the two bucket. So this is called data structure, storing and organizing. So need for data structure. Why do we need for data structure? A data structure helps you to understand the relationships of one data element with the other. Means you just have to study the relations of one data element with the other and organize it within the memory. Sometimes the organization might be simple: list of names of months in a year, linear data structure. For example, January, February, March, April, May, June. This is linear data structure. All the months in a year will fall in linear data structure. And a list of historical places in the world, non-linear. For example, you see recently happened Palgam, where it happened in Kashmir. We are sad about that incident, and a list of historical places in the world. For example, London, which is also called as historical place, and Kashmir, Kargil Yudh, where happened, and Jaisalmer, where India-Pakistan war was held. So a data structure helps you to analyze the data, store and organize in a logical and mathematical manner. Let's move to next page. So objectives. What are the objectives of data structure? Discuss primitive data types. We will discuss primitive data types, understand composite data types, explain linear and non-linear data structure. Okay, linear and non-linear, and after abstract data types. So without wasting time, we will move to types of data structures. Here as given here. So there are two types of data structures: primitive and non-primitive data structures. And after that, non-primitive data structures are converted into linear and non-linear data structures. Okay. And linear and non-linear, and you can write these things in your copy, and if you find this helpful, then you can note down. So this is called linear and non-linear data structure, and after linear is further divided into two parts: static and dynamic, and non-linear is tree and graph. So you can note down, and after that we will study primitive data structures. Without wasting our time, let's move to primitive data structures. Okay guys, let's move to primitive data structures. Primitive data structures are nothing but the basic data structures. Means if somebody asks you that what is the primitive data structure, then you will simply say that data structures are the basic data structures that directly operate upon the machine instructions. For example, so how machine works, all these happen with the machine's instructions, everything happens with machines instructions. Something is in my hair, it seems like something is in my hair. Okay, so this is a machine instructions. They have different representation of different computers. For example, integer, character, string are all primitive data types. Programmers can use these data types when creating variable in their programs. For example, if you have read programming language before, then you might have heard about variables. For example, uh, what are the variables like string, boolean, and what are the variables? For example, you must have heard about variables. Variables are those things which define the data, that which type of data will be stored. This is called variables container, for example, something which is stored. So variables do a work of container. You just nothing have to copy in your mind. You just have to copy in your mind the variables used as a container, okay, which stores data. Okay, let's move to non-primitive data. Okay, types of linear data structure as given below. Arrays. So before moving next, we will discuss arrays. So this is array. Let me copy something. With this, I will use navy blue type. So we will discuss array. This is array. For example, we will just draw a rectangular shape. For example, we have to store data in a array data structure. Okay, so we will first create one, two. We will start from 0, index 0. After that, 1, 2, 3, 4, 5. So in this manner we store data. So in types of linear data structure, we just completing arrays. Okay, so arrays is the first data structure, and data is stored in this manner. For example, if we have to store some numbers, so then it will start from index number 0, and from index number 0 we will move 0 1 2 3. So if somebody asks that how many are the numbers in this array. Okay, so we will simply say 1 2 3 4 5 6. Six elements are there, and the starting index number is 0. So let's move to and array can be further divided into two parts. Array is further divided into two parts, uh, one dimensional, two dimensional, and multi dimensional. One, let me, two, and multi dimensional. So arrays are further divided into multi dimensional. So now we will move to linked list. What do you mean by linked list? So if you are listening, then you might understand about list. What is list? You see train, how train moves from one box is connected to other box. You know, linked list. Linked list, as it named. Linked means connected to each other, and list, you see list as you see list of students when you go to college, then your attendance in MS Excel as a list 1 2 3 row in a row, say a student's name and these things like. So this is linked list. Linked list is a linear data structure which is used to maintain a list in the memory. Okay, it works as a list in the memory, and it can be seen as the collection of nodes and stored at non-contiguous memory location. It is non-contiguous. Linked list stores non-contiguous means not contiguous means continuous is what? For example, there is no gap. There will be continually move a row continually without any break, and so this is non-contiguous means discrete. This is like worked as a discrete. Each node of the list contains a pointer to the adjacent node. Means for example, if it is 1 and it is 2, then it is 7. So non-contiguous means directly moved to 7. So this is called data. So this is the linked list. You can simply say understand about it. So stack is a linear data structure, is a linear list in which insertions and deletions are okay. Only one end. You see piles of plates or deck of cards. You played. Have you ever played cards? Which is there's a king, a queen in a card. You might play. You might played. Okay. So this is a stack, and insertion and deletion is for example, uh, this is card. Okay, this is card. So this is card. So when you play card, then the insertion and deletion is starts from one end. This is the top. This is the top, and from here we switch the card. We switch the card one upon another, another upon another. So this is card. So this is a stack. So we completed a stack. So after that we will study queen. So after that we will study Q. So Q is a linear list in which elements can be insertion at the okay. Insertion will be done at that end, which is called a rear, and deletion will be done by front. So first in first out, and that is called first in LIFO and FIFO are the two terms which are connected with stack and queue. So you studied stack and queue. Okay. So let's move to next things. Brightness is something less here. Okay. Now it is good. So we studied stack and queue. Stack and queue, first in first out, storing the data items similar to stack. Queue is opened at both. Okay, have you seen insertion and deletion? Let me remember one example. Let me remember one example of queue. Queue is what is queue? You see. Have you ever played? Okay, this is the same method of switching. Means you see train, rail gari, and from top is front is engine of the train, and last is the back end of the train. So this is a train, example of queue, and and queue of queue of what I say. For example, insertion and deletion will be done with two different points. Uh, so this is queue. So move to non-linear data structures. Okay. Non-linear data structures. In non-linear data structures, first term is trees. Okay. For example, let me give you a example of tree. Okay. You see, this is your tree. This is your tree. After that, this is called. This is your root node. This is your leaf node. This is root. This is leaf. This is called leaf node. This is called leaf node. This is called root node. Let me erase this. So, bottommost node in the hierarchy is the leaf node, and while the topmost node is called the root node, as I shown, there. So this is called tree, and move to next thing. Graph. What is graph? Graph is another non-linear data structures. Graphs can be defined as the pictorial representation of the set of elements connected by the links known as edge. Okay, and a graph is different from tree in the sense that a graph can have cycle while the tree can't have the one. What do you mean by graphs? You see node. For example, let me give you example. Let me give you a brief example. You see graph like that. This is your square. This is called your no. This is called your diagonal. For example, so in this square, a graph is from differences in this sense can have cycle. Tree can't have the cycles. We can move from this place, this node. Let me switch to this different things. We can move from this node to this node to this node. So this is graph because ending and starting and end points are different, but this is the elements of the graph. This is your links connected by this is called your edge, this is called your vertices. Okay, so these are the things. Okay, so this is called your graph. Let's move to next page. Okay, we have already studied arrays, linked list, primitive. What do you mean by algorithm? Algorithm, have you studied mathematical formulas in mathematics? For example, any occurrence in the probability has the formula of 1 by 2, means uh, how many is the probability of coming head to in one what I say, one 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 dash, for example, that is something else. So when we toss up one coin, and what will be the probability of coming one head, so that will be like 1 by 2. So this is the formula. So in the same way, in data structure and algorithm, we study characteristics of an algorithm. An algorithm must follow the mentioned below characteristics. For example, input, output, feasibility, independent, unambiguous. So input, an algorithm must have zero or well defined inputs. Input, for example, something happened for we give input. Okay, then we get some output, for example, one or well defined outputs. Feasibility, an algorithm must be terminated after finite number of steps. In this feasibility, we count steps. Independent, an algorithm must have a step by step directions which is independent of any programming code. And unambiguous, an algorithm must be unambiguous and clear. Each of their steps and input and output must be clear and lead to only one meaning. The major categories of algorithms are given below. Sort algorithm, developed for sorting the items in certain order. Search algorithm, developed by searching the items in a data structure. Sorting, what do you mean by sorting? Algorithm developed by sorting the items in a certain order. In sort, we consider certain order. Okay, and in search algorithm, the searching the items inside a data structure. We studied stack, queue, tree, data structure. So this is searching is done in data structure, and sorting is done in a certain order. Okay, let's move to next page. Then deletion, algorithm developed for deleting. Insertion means input is coming from some side. Update, we updation of data. Time and space complexity of algorithms. What is time complexity? It is a way of representing the amount of time needed by a program. Okay, so here we end this lecture. What we studied: introduction to data structures. In this we studied data structures, stack and queue. What is a stack? From insertion and deletion is happened with the same place, same node. And what is queue? Queue is nothing but insertion and deletion is happened with two different points. So in this way we studied. So if you have any query, so you can write down. Thank you.